Throughout the course of Earth's evolution, numerous remarkable natural wonders have emerged. Each of these wonders possesses distinct compositions, ranging from majestic mountains to vast oceans and formidable volcanoes. Scientists have diligently studied these natural marvels, always on the lookout for new developments. Recently, an astonishing revelation unfolded as researchers unveiled the existence of an unprecedented mountain. Upon careful analysis, scientists ascertained that this newfound mountain surpasses the height of Mount Everest, the renowned pinnacle of our planet. Naturally, curiosity arises regarding the location of this extraordinary mountain and whether its climate poses similar dangers to those found on Everest. Join us as we delve into the captivating story of scientists' extraordinary discovery, a mountain surpassing Mount Everest in height. The measurement of a mountain's height is not a straightforward task, as these natural wonders can be evaluated through various methods, yielding differing ranges. Elevation can be determined based on adjacent plains or above sea level. However, measuring the true height of a mountain remains challenging. Standing majestically at a staggering 29,029 feet, Mount Everest reigns as the world's tallest mountain above sea level. Since the mid-19th century, the enigma surrounding this mighty mountain's height has been unraveled, solidifying its position as the highest point on our planet. Consequently, when discussions arise concerning Earth's highest point, a collective agreement swiftly confirms Mount Everest's status. In fact, the notion that Mount Everest holds this distinction has become so deeply ingrained in human consciousness that most individuals instinctively accept it without a second thought. Interestingly, prior to the recent discovery, theories challenging Everest's claim to the title of Earth's highest point had already emerged. These theories are rooted in a deeper understanding of our planet's unique characteristics, particularly pertaining to its shape. The shape of the Earth deviates from that of a perfect sphere, resembling more of an oblate spheroid. In this oblate spheroid, certain regions protrude from the center, particularly along the equator. Upon contemplation of this theory, it becomes apparent that the Himalayan mountain range, including Mount Everest, falls somewhat short in comparison. As scientists and researchers sought to unravel this phenomenon, recent measurements of the Earth were taken. The results revealed that our planet possesses a polar radius of 6,356.8 kilometers, while its equatorial radius measures 6,378.1 kilometers. In simpler terms, objects situated along the equator are approximately 22 kilometers farther away from the Earth's center than objects located at the poles. Naturally, there are variations in local geomorphology where objects in certain regions may be closer or farther from the Earth's center compared to others. One prominent exception to this pattern is the Mariana Trench, which represents the deepest point on Earth, reaching a staggering 35,797 feet below local sea level. In contrast, Mount Everest's elevation stands at 29,029 feet above local sea level. However, these two geological features exhibit only minor variations in relation to the overall shape of the Earth, accounting for 0.17% and 0.14%, respectively. In all honesty, Mount Everest remains one of the highest points on Earth, with its peak soaring to an altitude of over 8,848 meters above sea level. However, due to its location within the Nepalese Himalayan mountain chain at approximately 27 degrees and 59 minutes north of the equator, it is lower in elevation compared to mountains found in Ecuador. It is in this particular area of Ecuador, influenced by the Andes mountain chain, where the highest point on Earth can be found. The summit of Mount Chimborazo in Ecuador claims the distinction of being the highest point on Earth. Despite ranking as the 39th tallest mountain in the Andes mountain range, Mount Chimborazo secures this title due to the Earth's oblate spheroid shape, influenced by the gravitational force. The swelling of the Earth occurs around the center of the equator. While Mount Chimborazo is not among the tallest mountains when measured from sea level, it confidently sits on this bulging equator, positioned 7,096 feet farther from the Earth's center than Mount Everest's summit. Located between Guayaquil and Quito, Mount Chimborazo was originally an inactive volcano. It encompasses several summits, including Polytechnica, Whymper, and Nicolas Martinez. Among them, Whymper marks the highest point on the mountain. The etymology of the name, Chimborazo, remains somewhat uncertain. According to some tales, it is believed to be a combination of the Quiapa word, Xingbu, meaning women, and the Quechua word, Raza, signifying snow. Thus, the translation would imply women of snow. However, locals who are familiar with the mountain refer to it as Urkaraza, meaning mountain of ice, casting doubt on the accuracy of these accounts. For a considerable time, Mount Chimborazo was widely regarded as the highest mountain in the world until the 19th century. Numerous endeavors were made to reach its summit, including the French geodesic mission in 1746. Although the team fell short of reaching the top, their work substantiated the Earth's oblate spheroid shape. The map of Ecuador, crafted in 1858 by Manuel Villavicencio, reinforced the information gathered by the French mission and other early explorers, such as Alexander von Humboldt. Known for his significant contributions as an explorer, geographer, cartographer, and scientist, Alexander von Humboldt extensively explored South and Central America between 1799 and 1804. In 1802, Alexander von Humboldt arrived in Ecuador with the intention of conquering the summit of Chimborazo. As the climbing party ascended to a height of 15,600 feet, most of the members decided against proceeding further. However, Humboldt continued the expedition alongside his travel companion Aimé Bonpland and an Ecuadorian guide named Carlos Montufar. Mount Chimborazo's peak stands at an elevation of 6,263.47 meters above sea level. Due to its location at just 1 degree and 28 minutes south of the equator, precisely at the highest point of the planet's bulge, Mount Chimborazo enjoys a natural advantage of approximately 21 kilometers. When comparing Mount Everest and Chimborazo in terms of their distance from the Earth's center, Everest is situated 3,965 miles away from the geocenter, while Chimborazo reaches a distance of 3,967 miles. This leaves us with a mere 2-mile difference in measurements. Although this discrepancy may seem insignificant, accuracy is paramount when discussing titles and rankings. Despite the analysis conducted by scientists and researchers, some individuals may argue that Mount Everest remains the tallest mountain on Earth. However, it is important to note that such assertions would be incorrect. The true tallest mountain in the world, in factual terms, is Mauna Kea, a dormant volcano located on the island of Hawaii. This mountain measures 33,484 feet from its base to its peak, thus deserving the distinction of being the highest mountain globally. Unfortunately, we can only appreciate a portion of Mauna Kea, as its base lies several thousand meters below sea level. Consequently, we can only admire its prominent summit, which reaches an impressive height of 13,802 feet. While it is true that Everest holds the title of the tallest mountain based on its summit elevation above sea level, measuring mountains, especially during the 19th century, was no easy feat. The absence of GPS and the limited accuracy of altimeters presented significant challenges in obtaining accurate measurements of Earth's geography. The process of measuring mountains was a daunting task that demanded thousands of person-hours, extensive trigonometry, and nearly a century of effort to achieve precise results. The measurement of Mount Everest began with the successor of Sir George Everest, Andrew Waugh, who initiated a comprehensive survey of the Himalayas. During the survey, Waugh's team employed the triangulation method to measure Everest. This method involved observers strategically positioning themselves at various points, meticulously determining the distances between these points and the mountain's peaks. By calculating the angles from the observation points to Everest's summit, they could derive its height. However, in order to establish the measurement above sea level, the observers had to determine their own elevation relative to sea level. Basic trigonometry was utilized to calculate the mountain's height in relation to the observer. Considering the absence of modern technologies, the challenges faced by these early surveyors highlight the arduous process involved in accurately measuring the heights of mountains like Everest. Regrettably, the team encountered difficulties caused by atmospheric refraction, a phenomenon where light bends as it passes through different air densities over long distances. This refraction produces a mirage-like effect, distorting the perceived height of objects and making them appear taller or shorter than their actual measurements. This effect becomes more pronounced over extended distances, and other factors exacerbated the situation. One such factor was the imposition of political restrictions, preventing surveyors from getting close to the mountain. Consequently, most of WAR's observations had to be conducted from over 100 miles away. Despite these challenges, the surveys managed to derive an incredibly precise measurement of 29,002 feet for Mount Everest. Over the next century, the mountain was measured multiple times to verify this figure once access was granted for closer observations. Subsequently, an additional 27 feet were added to the mountain's height. In today's modern world, the process of measuring altitudes and achieving accurate results has been greatly simplified with the advent of satellites and GPS technology. Nonetheless, a lingering challenge persists when it comes to these mountains. Take the Himalayas, for instance. This majestic range owes its existence to the ongoing collision between the Indian Plate and the Eurasian Plate. Consequently, the region remains highly active seismically, with frequent earthquakes impacting its elevation. While some quakes may have minimal effects, such as a slight reduction in summit rock due to landslides, fault movements can swiftly raise elevation by as much as 5 meters. Consequently, entire sections of the range experience upward movement each year. Furthermore, there are additional complexities to consider. For instance, scientists and researchers ponder over whether snow and ice should be included in a mountain's height measurements. This further complicates the task of accurately determining a mountain's peak. However, mere assumptions hold little value on a planet that undergoes constant change. Nevertheless, these mountains continue to captivate the attention of scientists, researchers, geologists, and adventurers alike. They serve as a focal point for exploration and discovery, guaranteeing an enduring fascination for years to come. We invite you to share your thoughts on this matter in the comments section below.